So on Feb 15, this is sort of just 2 weeks ago, Google launched a new model. Finally, they came up with a model that might actually challenge OpenAI's GPT-4, Gemini 1.5. And the big selling point on Gemini 1.5 is the size of the context window. The context window is basically how many tokens, and a token is about a word, the model can either input or output. It depends on the limits. There's limits on inputs and outputs, but how many tokens you can send to the model and it can process. Until Gemini 1.5, we were used to models that were limited in the 10, it started when they first came out, you'd have like a 4K limit on tokens. Then we got bigger, like Claude came out with 100K, and now GPT-4 is at 128K. And Claude 2.1 moved up to 200K. But Gemini, out of the box, claims Gemini 1.5 claims 1.5 million tokens, 1 million tokens, sorry, and it will scale up. In the paper that accompanied the model, they said they would scale up to 10 million, and they'd done some testing. So just there's a diagram here. You can see how much more context the LLM can process. So this led to a bunch of hot takes, on Twitter, LinkedIn, social media, Reddit. RAG is dead. We don't need RAG anymore. And I think that's not a correct call, but I can see the argument, right? The argument is that, well, one of the reasons why you do RAG, but just one of them, one of the reasons why we did RAG, especially back in the early days, was GPT-4 had a 4K context window, so you had to be really picky about what kind of information, because RAG, you're doing retrieval augmented generation, so you're retrieving documents from your vector database, and you're basically stuffing those into the prompt that you send to the LLM and say, given this information, come up with a response, a generated response. So RAG was a solution to that we had limited context window, and now we have seemingly unlimited context window, or like practically unlimited context window. So we don't need RAG anymore. That was kind of the argument that was being thrown out there. I don't think that's quite true. Can you show the next slide, Chris, please?
Sure.
So, RAG is dead. No, long live RAG. I think that RAG is far from dead. So let's first look at whether it can actually, context window, we can give it all those tokens, but can it actually use those? And it came out in the summer. There's a paper from Stanford, introduced the concept when longer context windows were starting to roll out from some of the providers. There was a paper with this idea that lost in the middle. So the paper demonstrated that the information at the beginning of the context window was always used, actually, and the information data at the end of the context window was well used, but the stuff in the middle of the context window, the LLMs didn't really use that very well. So that was the lost in the middle concept. And so that was kind of like, context windows are great, and it makes things a little bit easier because you don't have to worry about being very, very careful about how big your context window is. But we don't really get a lot of value out of that. When Google came out with their Gemini model, they wanted to sort of prove that the whole context window could be used. And so one of the things that they did is they picked up on this needle in the haystack test. This originally came out from, it was interesting, just somebody on Twitter, Greg Camrant, sort of did this experiment. He took one of the longer context window models at the time, and he said, well, I'm going to fill that context window up with random statements, random facts. And then I'm going to put it at different places in the context window. And then I'm going to ask the LLM, can it retrieve that fact from the context window? This is the needle in the haystack test, right? And the chart at the top is the original findings for that. And you can see in the green is like, it could find the needle in the haystack, but it got really bad at finding the needle in the haystack as the context window got longer, and depending on sort of where you put it in the context window. Front of the context window, doesn't matter how big the window was, it was good. You got into the later parts of the context window, hard time finding that fact, trying to find the needle in the haystack. And so that was another reason why it's like, yeah, these context windows are great, but we still are better off, curating the best content and putting it in the context window up near the front. even if it has a large reach, a large size. Um, so Google came out and in the Gemini paper said, "Oh, well, we ace the needle in the haystack test," and it's true. They published the data. They can find the needle in the haystack, across most of the context window, like in 99% retrieval of the needle in the haystack, and that's a great achievement. The question is needle in the haystack really a realistic test? It's not, in my opinion. This is not what you're actually doing. It's not when you're building RAG applications, you're building chatbots, you're building any kind of tool on this, you're not doing like Where's Waldo, right? You're actually, want to use all of the context, not one random fact in there. So I don't think it's all that realistic. And so it's great that they've solved that problem. Not sure that it's actually going to translate to real world solutions. And in fact, in the Google paper, they admitted this. They said, the needle in the haystack test is the simplest possible setup. And they did another test where they would do multiple needles in the haystack. And that's the second graph. This is, in my mind, figure 10. The figure, I remember when this came out and I started reading the paper, I immediately sent it to Chris. I said, figure 10 is the reason why the long context window is not going to actually kill RAG. You can see from this scatter diagram, and they've, interestingly, everyone wants to knock GPT-4 off the mantle. So this is comparing GPT-4 to Gemini 1.5, and how good a job it did at recalling multiple needles in the haystack at different context lengths. And red is GPT-4, and GPT-4's context window is 128K, so that's why it's only the sort of leftmost part of the scatter diagram. And you can see it's not that great. It's like getting around 50% recall, and it gets like worse if you look sort of the trend line down. Gemini 1.5 does a better job. You're going to kind of maybe slightly downward sloping line you would draw through that. But you look at where it actually is in the recall, it's around 60%. So it's only able to even find, and this is not even that sophisticated a test, it's just a few more needles to find in the haystack. It's missing 40% of the data that you're sending to it. So it's maybe able to find one needle, but it's still omitting a lot of the information. By Google's own results suggest that it's not able to use much of that context window. The other thing to note is that there was a paper that came out just last week, or maybe it was this week, I don't know, it's all a blur to me, that you might want to check out. And it's not talking about these super long context windows, but it's more exploration into longer contexts and how well LLMs can use them. And I link it in here, and I can share it with you if you're interested. It's called Same Task, More Tokens, exploration of long context windows. That also, if you look at the conclusions from that, is that, as the context gets longer, you see degradation in the ability of the LLM to use the context window. So that's kind of the first thing. It's like, yeah, we have a lot of context, and it's certainly a great achievement, the size, because it's order of magnitude bigger than anything else. But you may be putting all this into the prompt. The LLM is not really going to make great use of it. Next slide, please. So the other thing you have to keep in mind for these long context windows is exactly what the trade-offs are. I mean, nothing comes for free, right? LLMs, to start with, require a lot of CPU and a lot of memory just to run them, which is why NVIDIA's share price is where it is right now, right? And so, if you're going to give an LLM this much data, and by the way, I have a friend who works at AMD. He's telling me, like, if you're putting that much memory, if you're stuffing that much into a memory access for LLM, it's not optimized for accessing that much data, just by the way it's structured. He said it's going to be slow at accessing the data, and that's true. LLMs are not optimized for processing this much data. And so your early returns on Gemini 1.5 to do 360 context, 600K context window, 30 seconds to 1 minute. So you're waiting a long time. Like, that feels like, if it's an interactive application, that's like an eternity. That's a bounce. I think it's broken, I'm going to go leave kind of response. And even if you don't have an interactive application, some kind of background task, I mean, if you have to wait 1 minute to process one LLM generation, your throughput isn't so good, since there's an inverse relationship between latency and throughput, right? You can only go so fast. So this becomes a very slow process of generation. Um, and then the other thing to keep in mind is how much is the actual cost of it. Um, if we don't know the pricing yet of Gemini 1.5. Google hasn't released it. And in a lot of the tests, a lot of the reasoning tests in the leaderboard, it is pretty equivalent. It's pretty close to GPT-4 Turbo. Uh, if Google came out, and they probably won't, it'll probably be less than that. But if they came out with GPT-4 Turbo pricing for Gemini 1.5, 1 million tokens would cost $10. $10 for one question to your chatbot. So that's kind of the worst case scenario. If OpenAI was doing this, this is what it would cost. If we use what sort of the existing Gemini pricing is, it's quite a bit less than that. But it's still coming out, and the pricing on Gemini and in OpenAI, it's priced by token. In Gemini, in Google Gemini, it's priced by character. If we assume like 4 characters per token on average, it works out to about 50 cents for 1 million tokens. Still a lot of money, actually, because you're looking at 50 cents per question on your chatbot. That adds up pretty fast. That's certainly not something you want to leave, let anyone in the world use your chatbot. End up racking up hundreds of dollars in a day, people just asking random questions. And that's just, imagine a situation where someone's asked 15 questions in a short amount of time. Like this has cost you $10, something like that, right? So that's a trade-off. Latency and cost. Right now, these problems are not solved. It's going to cost you a lot of money to run long contexts, and the latency is going to be really bad. Next slide. The other thing is, if you think about this from a sort of a engineering perspective, is 1 million tokens is kind of a brute force solution. Is I don't want to think about finding the best information to give to put in the context. I'm just going to give it all I got, right? That can work, right? But it is brute force. So what happens is, imagine a scenario where you've built this. Say you have this working your RAG application, and now your RAG application, as Chris was mentioning, is giving poor responses, or it's hallucinating. Okay, well, now what are we going to do about it? There's not much we can do with the brute force solution. We can't. There's no knobs for us to tune. All we do is basically dump all the data into it and hope that we get a good answer. And so I think what happens is you can give it more data, you can give it less data, but I think what happens over time, you end up building it's well, maybe the only logical thing to do is to give it better data. And so you end up building a traditional RAG application anyway, where instead of sending it 1 million tokens, you're going to send it the best 10,000 tokens. And then you're just doing a traditional RAG application anyway. The other thing to keep in mind is if you've built any kind of scaled kind of system, getting 1 million tokens into the LLM, the engineering problem is not trivial, because even if the LLM was down to 100 milliseconds to process that 1 million context window, that would be great. If it takes you 2 minutes to retrieve 1 million tokens worth of data and pass it into the LLM, the overall process is still very slow. And so you need to think about that. Is how do I get 1 million tokens into my LLM per call? Not a trivial problem. Do you pre-extract the data? If it's sitting in PDFs, you probably pre-extract it, because you don't want to extract it every time from the PDFs, the text. So then now you got to put it into a database, and now we have to recall from a database. And you know what? You're still doing RAG, right? We're doing RAG no matter what. We're augmenting the generation with retrieved data. So RAG is not dead. RAG is a pattern that I don't think will go away, even if the context windows even get bigger, the costs come down, the latency comes down. You're going to do RAG. Maybe you don't need a sophisticated vector search, and maybe there's some simplification you can make in the pipeline, but I think RAG is here to stay for sure.